Welcome back to the part 3, the last part, the writing part. There are 3 questions in this, but all of them carry total of 20 marks. And there are 2 more bonus questions in writing, which is 5 marks each. So they carry 10 marks. Total writing is of 30 marks. Please do practice them by writing. Don't just look into the videos. Understand and then try solving problems by yourselves. That is how you will learn and remember for your exam. Now we will continue, but before I continue, I would like to request you all, if you find this channel useful, if you're watching my videos, please do subscribe to it. And I want to thank all those who have subscribed. I greatly appreciate it. It means a lot. Do subscribe, like, and share it among your friends. Now we will move to the 21st topic. Write the specified type of proof. 2-column proof given NP. See over here, they have given some stuff that is NP is equal to PM. NP and PL are congruent. Okay, this is, sorry, not congruent, perpendicular. It's 90 degree. If it's perpendicular, this is the sign, it's 90 degree. We need to prove these congruent. And look over here, they have mentioned SAS postulate. That means side, angle, side. Looking at this figure, I can easily tell that NP and PM are congruent. These two right angles are obviously congruent, and PL is congruent because of reflexive property. But we need to write in proper way. So first, let's write this statement. NP equals PM, and this given, all we do is given statement. This PL and NP are perpendicular. That means these angles are 90 degrees. Okay. From this NP equals PM, that means the line are congruent to each other. If this is phi, this is phi. That's what it means, equal to. That means these lines are congruent as well. Okay, that's the definition of congruency. Equal means the lines will be congruent. Then we have this angles, right? Since it's told perpendicular, then they are right angles. So here MPL and NPL are right angles. So perpendicular lines form right angles and they are congruent. If both are right angles, obviously they'll be congruent, isn't it? 90 degree, 90 degree. Then what else? PL is the same line for both the triangles. It's from the reflexive property. So now we have the side, this angle and side. So from SAS postulate, we can prove that the triangle NPL will be congruent. If you start from N, remember you must start from M over here, NPL. That's the answer. But it must be written in detail. The figure will tell you everything. So make sure first start with the given and then write the remaining parts. Look at the figure, write them as it is. If you're getting confused, just write NP and PM. Write it over there, just as it is, and make sure you put the angles and solve it up. So that's it. Make sure you mention this in the bracket, or you can do a column, say like this, 2 columns. Statement and reason, it's up to you. You can just write statement, reason, and then first, what is the reason? Say NP is congruent to NP. It's given. So that's the thing. Just whatever it is, you can do it. Similarly, now we have one more problem over here, 2-column proof. So statements and reasons. They have given a lot of things. Let's write it. AB equals CD. They have told it's equal. Then they have also told AB is parallel to CD. Okay. So now, if this is the thing, if it's parallel, always remember, we have done this before in part 2 as well. Whenever there is parallel stuff, the alternate interior angle theorem comes in picture. You can see BAD and CDA are congruent. Why? Because these are parallel, so these are interior angles. That's it. Next, AD and AD is the same because it's a reflexive property. It's the same, right? They're reflexive property. And over here they have mentioned AB and CD. It's given. They have told it's equal. So we can tell they are congruent because of the definition of congruent segments. So basically you have S side, angle, and again another side. That's a SAS postulate. So please, over here they have asked paragraph proof. But it's fine, you just write any one of it. Make sure you write it. That's the most important thing. Now over here it's the same thing, just that V is the midpoint of W and X. If that is the case, then these both are equal because from the midpoint theorem. That's it. And then they have told even for this angle, sorry, this line and this line, it's the midpoint. That means this line is equal to these are all equal to each other, okay? And then there's vertical angles, just that, SAS. So you can see over here there is vertical angle theorem, midpoint theorem. That's more than enough to prove this side is equal to this side is equal to this side, and vertical angles prove that all this is a SAS postulate. Similarly, please do try these by yourselves. Most of the things are given over here. It's very simple. They have asked a flowchart, given, literally everything is given, and then just that over here, literally everything is given. See, PR is congruent to DE, PT is congruent to DF, and they have told R is congruent to E, and then T is congruent to F. And obviously all the angles will be equal then, because the third angle, if two angles are equal, the third angle must be equal. That's called third angles theorem. And then you have literally so many things, but you can tell SAS or all the see, the thing is, if all the angles are equal, that's not enough to make it congruent. It can make it similar. Length might differ. So two sides must be known, at least two sides. In this case, see, this side and this side is congruent. So whenever two sides are congruent, and then, okay, there's one more thing. I understand why now it is important. It's SAS. Remember, the side. The angle must be in between. Look at this. This is not enough. Angle is outside. This angle must be congruent. So it's very important to write the statement. Otherwise, it's not SAS postulate. So that is very crucial. So what happens? These two angles are given. So you tell this angle is congruent. Then you get SAS postulate. And similarly over here as well, they have given a lot of stuff. Make a 2-column proof. Here, see now one more thing. If they tell bisection, see BD is bisecting AC. Bisection means it is cutting into right. Over here you can see BD is bisecting, right? Now then that means it cuts into equal angles. Bisect, now if you have an angle over here, you bisect it, it makes into equal parts. Please remember that. So that is very important. Bisection will make equal angles. Over here in this case it's a straight line, so it will be right angles. And then you can look through this, see the statements and look at the figure. It's very straightforward. Make sure you solve them by yourselves and then check for the answers, because they're pretty easy. And that's basically it for the 21st topic. Remember, it's SAS postulate. You must have side over here, side, and angle in between the two sides. That's it. So in the next video, we will continue with the next topic, that is topic number 22.